All right, so when solving trig equations, I guess the one thing to really take into account is that there's an infinite number of solutions. Our sine, cosine, tan functions go on indefinitely, okay? So there's an indefinite number of solutions. So what we do is we typically find the solutions over a particular domain that we're interested in, all right? So the process is always going to be determine, we want to determine the quadrant angle, the first quadrant angle that solves the equation regardless of the sign. So if we're looking to find out where sine x is equal to a half, well, what angle gives me a half for sine? And that's 30 degrees or pi on 6. So that's the first thing we're looking to do. We want to find out which quadrant or the first quadrant angle for theta. The next thing we do is work out if we're looking for a positive or negative. If I want to work out where sine x is equal to negative a half, well, I then determine, well, which quadrants is sine negative in, and that's in the third and fourth quadrants, all right? And then once I get my first two solutions, all right, the first two solutions are those that occur between 0 and 2 pi, or 0 and 360. Once you've got those two, you then just add and subtract the period continuously until you end up with solutions that are outside the domain that we're interested in. All right, so first things first, let's have a look at, find the solutions to the equation of sine x equal to 1 on root 2. So the first quadrant angle, or what I call the base angle, is where x is equal to sine inverse of 1 on root 2. So in other words, sine of what angle is equal to 1 on root 2, and that's pi on 4. All right, because my domain is in radians, my answers will be in radians. So that's the first thing I want to do. The next thing I'm going to do is just do a little crosshair here and say, righto, I need sine x equal to positive 1 on root 2. So whereabouts is sine positive? It's in the first and second quadrants. So they're the two angles that I'm interested in. All right. And so then my angle, which in this case is x, is equal to, well, this angle here is just pi on 4 degrees. This angle around to here, okay, well, that's actually equal to, well, there's pi minus pi on 4. And pi minus pi on 4 is 4 on 4 minus 1 on 4, which is, and I'll put it in red, 3 pi on 4. There's my first two solutions, all right? So what I do from there is add and subtract the period, which in this case, the period is equal to 2 pi, which is 8 on 4, isn't it? All right, so my two other solutions, if I want to get my next two set of solutions, pi on 4 plus 8 on 4 is 9 pi on 4. 3 pi on 4 plus 8 pi on 4 is 11 pi on 4. They're the next two solutions. If I want to get the next two, I add another 8 on 4. Since we've got to consider the negative direction, let's subtract. Let's subtract 8 pi on 4 from both. So two more solutions will be pi on 4 minus 8 pi on 4, which is negative 7 pi on 4. 3 pi on 4 minus 8 pi on 4, negative 5 pi on 4. So they're all solutions. I could subtract another 2 pi if I want to get two more. Now, what we need to do now is consider the domain that we've been given. And I'm only interested in the values that are in between the domain that we've been told. So it's got to be between negative pi, and the negative ones are both too large, if you like, in size. So the only two solutions that fit are pi on 4 and 3 pi on 4. All right. So I guess if we were just to do a little quick graph sketch, the period is 2 pi. So the graph might look a little bit like that. Yeah, and we'll go to negative pi. So there's my graph. And we want to know where it equals 1 on root 2. Well, 1 on root 2 is about 0.7071, which is around here somewhere, say. So we can see graphically, I only expect 2 solutions anyway. All right. If we were looking for negative, 1 on root 2, obviously there's a few more down underneath the axis. All right. So there's the 2 solutions that I was after. All right, let's have another go at that process. This time I've got cos x is equal to -1/2. So again, I'm just going to focus on my base angle. So x is equal to cos inverse. I'm not going to worry about the sine. Cos inverse of 1/2. So what angle gives me, cos of what angle is 1/2? And that's equal to pi on 3 or 60 degrees. I'm then going to look at my crosshairs and say, rather, which quadrants? I need where it's equal to -1/2. So where is cosine negative? Cosine negative is there and there in those 2 quadrants where the x value is negative. So there's my angle there. So now my angle here, which is x is equal to, we'll start at 0. I'm going to go around to pi and then subtract pi on 3. And the next one is around to pi plus pi on 3. So my first 2 solutions are at 3 on 3 minus 1 on 3, which is 2 on 3. 3 on 3 plus 1, which is 4 pi on 3. So there's my first 2 solutions. And now again, I'm going to add and subtract the period to give me a few more solutions. So let's go with the subtraction of it first. X is equal to, if I subtract, again, the period is 8 pi on 4. Sorry, there's no point writing 8 pi on 4 because since I'm working in thirds, I'm going to write 2 pi, which is 6 on 3. So 2 on 3 minus 6 on 3 is -4 pi on 3. And then I've got 4 pi on 3 minus 6 pi on 3 is -2 pi on 3. Then I'm going to have my 2 solutions that I've just worked out. Then I'm going to add 6 on 3 to both of those. So 2 on 3 plus 6 on 3 is 8 on 3. And look, I will put the other one. 4 plus 6 is 10 on 3. And so from here, I'm going to look at my solution and say, right, which ones fit in between -pi and 2 pi? So these 3 here, aren't they? 8 on 3 is a little bit over 2. And -4 pi on 3 is a little bit under -pi. So the solutions that I'm after, and maybe I should, I could write it over here, are those. If I do a quick graph sketch, again, cosine, period of 2 pi. Just going to make that a little bit bigger for us. There's 2 pi there. Halfway mark at pi. Yeah, and let's go back. And I want to know where my graph is equal to -1/2, which looks about there. So I just do a horizontal line there. You can see there, that's where my 3 solutions are. So and what are they at? -2 pi on 3. -2 pi on 3. I just can't remember. 2 pi on 3 and 4 pi on 3. Which all seem fairly reasonable, okay, in terms of solutions. All right. Find solutions to the equation 2 sine x plus root 3 equal to 0 between -90 and 360. So this time we've been given a domain in degrees. so we can work in degrees. All right, same sort of thing. So let's rearrange this graph. So 2 sine x equals negative root 3. Sine x is equal to negative root 3 on 2. So again, let's work out sine of what angle is equal to root 3 on 2. Not fussed about the negative sign. So sine of what angle is root 3 on 2. So x is equal to 60 degrees. Then we decide, okay, I'm looking for where sine is equal to negative 60 degrees and sine is negative in the third and fourth quadrants where my y values are negative. So my first two solutions are starting from 0 around to 180 plus 60. So I'm going to get x is equal to 240 degrees, and then all the way around to 360 minus 60, which is 300 degrees. So there's my first two solutions. All right, my period again is 2 pi, which is 360 degrees. So if I subtract 360 from both of those, 240 minus 360 is negative 120. 300 minus 360 is negative 60. Then I get my 240, 300. And then if I add 360, I'm going to get 800, 500, 600, 360, 600 degrees, and 660 degrees. All right. I'm interested in between negative 90 and 360. So which ones is that? Which ones is that? Which angles? They're the solutions that I'm interested in. All right. So again, I guess if I was to sketch this graph, 2 sine x, so again, my period is 360. So I'm going to do it in 2 steps. So 2 sine x means there's my 90, there's my 270. So as a graph, oh, I don't like that. So there's my 2 sine x plus root 3. So root 3 is about 1.7, isn't it? So that means that everything's going to move up about 1.7. Is that right? Yeah, I think that's about right. Well, it's less than 2 anyway. So we'll call that about root 3 there. So every point's going to go up. These points will still be a bit below. And what's a good idea when we do a vertical shift is just do that. It's not an asymptote, but sort of that axis. Redraw the axis. So you know that now that was where the x-intercept was. That at 180, that's where the x-intercept was. That's where the x-intercept was. So now I can sort of go, okay, well, that point's up there. It's going to come down to there, go roughly down through there. And we're going to continue on in the negative direction. So if we match those up to our angles, well, the last one's not very accurate. 240 and 300, does that seem reasonable? Yeah, probably could have drawn them a little bit steeper, couldn't I? So by rights, 240, 300 is probably there. So let's just get that a little bit better. So maybe 300, so maybe we're going to come down through there. up like that. And obviously at this back end, the other angle should be at -60, which is back here somewhere. So it must come down about through like that. All right. So again, that gives us an idea of the x-intercepts, if you like, of 2 sine x plus √3 equal to 0. Or it should also correspond where sine x is equal to -√3 on 2, which is about there. All right, off you go.